Okay, I'm gonna zoom in. If you just came in, don't worry, you didn't miss anything. There was very small amount of structure to lay out. Okay, here we go. Two sample T interval for mu1 minus mu2. Shocking. Okay. State percent, like blank percent, confidence interval for mu1 minus mu2 equals the true difference in means of well, I have so many lines there, but I do want to add one more thing. So we're going to make a note to ourselves here. So something percent confidence interval for mu1 minus mu2 equals the true difference in means of some kind of context. Let's say context 1 and context 2. And it's basically like what you're subtracting. So I want to make a note here. Either use mm, just trying to figure out what I want to, how I want to say this so that it makes sense, but I don't make you write a bunch of extra stuff. Okay, write that down and then tell me if that makes sense to you, like what I'm trying to say there. So I'm trying to say that you either choose labels that make sense for the first thing minus the second thing, like letter labels, like algae minus microorganisms. Wow. That's a really random situation. Okay, you can either label the letters in your order of subtraction, or you can use 1 minus 2 as numbers and put something in parentheses that labels your order of subtraction in words. Does that make sense? I know we've done this before. I don't really know why I'm having such a hard time describing what it is that I would like you to do. The fact that I think you already know because we've done it before. I'm gonna choose the letter labels as many times as possible because I'm lazy and I don't want to have to write the parenthesis deal. But if you like using the numbers, by all means. Anyway, wow, why is that so rough for me? I don't know, but it's forever commemorated on video now. So, great. Okay, what would be the inference method for this? Mm-hmm. It's the title of the thing. And really quick, I leave these as numbers every time because this inference method is just a generic statement of what the procedure I'm going to use. So these I leave numbers, but I'll put the specific letters up in the problem because of context. Okay, so random. What's the note here? What do we need to remember about randomness when there's two samples? Yes, check. I'm not going to say independent because you're going to get confused.
You won't probably get confused. I'm just gonna. So check that samples are random and separate, or that you have random assignment, some kind of randomness. Okay, now let's be very specific here. You have to put it n equals twice. You have to put it twice. You have to list it twice. You have to say it twice. You have to write it twice. You cannot bundle it all into one thing, and you cannot put the little like lazy person quotation marks underneath. Nope. I mean, can you do that on on your homework? Sure. Test or quiz, any sort of assessment, make sure you write it all out. Okay, so N1 equals blank. Or if it says random assignment, 10% condition does not apply, which is great. Mrs. Talbot, you left way too much room up here. And now on this one, you don't even mention large counts. Where did your large counts condition go? What happened? And it just appears as though I'm gonna have to move the do down a line. Or you can put it over here if you'd rather. Okay. What do we do for large counts for means? Perfect. Okay. However, how many n's are there in this particular thing? Okay, so okay, here's the thing. Because you might have two different sample sizes, one of them might be over 30 and one of them might not be over 30. They both might be over 30 or they both might be less than 30. Does that make sense? Okay, you only have to do the graph for if it's less than 30 for one of them. So that it's like completely separate things. If they're both greater than or equal to 30, you're great. You just move on. If one of them is, you have to do one graph. One of them is less than 30, you have to do one graph, and both of them are less than 30, you have to do two graphs. Now I'm going to direct you down to the very, very sad news about the example that we're doing. What are the sample sizes in the example that you just pasted into your? Yeah, we have to do it. We have to practice it. So, I know. I know. Okay. All right. Now, the do step, yellow sheet, confidence interval, statistic. What is the statistic for a two sample t interval for mu1 minus mu2? Okay, let me ask this again. What is the statistic for a two-sample t interval for mu1 minus mu2? Nope. Nice. Good job. X bar 1 minus X bar 2. I'm going to put that in parentheses because I want you to see that that's going to combine to be one number. Okay, if you ever blank on that, it's right here. Again, if you ever blank on what that is, it's right here for you. Okay. Plus or minus. Critical value is, we're working with means, so it's T star times, okay, and then standard error is this guy. Gigantical square root S of x 1 squared over n1 plus S of x 2 squared over n2. Okay, so pause here really quickly, just quick pause. Pretend that I, had like a serious cramp in the quad, not the outside quad, like the leg quad. And I was like, oh my goodness, I can't possibly teach this. You guys are gonna have to figure it out today. Like, what happened if I had like a toe cramp, a really severe dehydration toe cramp? Have you ever had a dehydration toe cramp before? No, it's a real thing. Like, if you're dehydrated and then like, I have this thing, okay, so like, this is really weird, but I put lotion on and I feel like this, right? And then you point your toes and then all of a sudden you're super dehydrated, so you, no. Anyway, I run, so maybe it's a runner's thing, but, so, okay, what I'm getting at. I'm trying to make you laugh, but what I'm getting at is really, how much of this did you need me to teach you? None. Really, I bet if I was like, guys, it's super important that you guys write the outline for how to do a two sample confidence interval for means, and you use your yellow sheet and you use your prior knowledge. I'm pretty sure almost everyone in here could come up with almost all of this on their own, just because we've done it so many times now, and it just really isn't that surprising. Isn't that great? That's good stuff. Okay. So moving on down, did you paste your dealio in? Can you imagine the year that I made the children write this down before Mr. Talbot's idea to make these things?
Okay, really quick thing I wanna point out is, I have. On this problem, I think I told from the book, but in this problem over here. This part of the table, these are summary statistics, which means that there's stuff already calculated for you that you can use in the problem. But this doesn't always happen. I just wanted to remind you that one variable stack is a thing. So you could, if you had this problem, you could type all of those into L1 and then run one variable stack and get those two. And you could type that one into L1 and run one variable stack and get those two. I just wanted to remind you that that thing exists. But for time purposes, that's not what we're testing right now. We're just using this stuff they gave us. Yes. The last problem was TCDF, I believe. Yes. Well, you do like, wait, put in a stop plot or box plot? Well, you have it on the. Let me look. Look, can I look after I finish this? Okay. Was it like, it wasn't like the 1.5 times IQR rule from chapter 1? Okay. Okay. 20 students were randomly assigned. Oh, hey. Randomly assigned. That means I get to skip the 10% condition. Woohoo! To 2 treatment groups, caffeine and no caffeine. Yikes. I don't want to be in the no caffeine group. Each of the 10 students in the first group drank 12 ounces of cola with caffeine, and the others drank caffeine-free cola. Cola. All students measured their pulse rate before and after. The results are in the table below. La-di-da-di-da-di-da. Construct and interpret a 95% confidence interval for the true mean difference in pulse rate for students like these who drink caffeine versus those who do not drink caffeine. Cool. 95% confidence interval for mu C minus mu N. Does that work for you guys? Do you see where I got the C and N from? Were those the letters you would have picked? Okay, just checking. Okay, now I want to note here that you could write this differently. You could write mu C equals MUN equals and put the two statements separately. I don't care which one you do. This one is less writing, which we can all appreciate. Okay. First of all, does my state make sense before I move on? And you could also say change in pulse rate instead of pulse rate change. If you want to just copy off of what they have, that's fine too. I was just trying to make it less wordy. Okay, plant 2 sample T interval for mu1 minus mu2.
Okay, now again, this bit right here, you don't have to write that 10% does not apply. You could skip that completely. I just can't do it. I just can't seem to do it. I have to address it. It's a personality flaw. It's not you, it's me. I feel like I just can't just completely skip it like I did something wrong. I don't know. You can skip it if you want to. Just completely skip that. Can't do it. I don't know why. Oh yeah. It goes 6 lines past the middle hole. Okay, but the reason is because we have to make dot plots. It's not because it's like this. The dot. Oh, no, 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 no. The large counts condition takes a very large amount of space, is what I'm trying to say. Okay, do you guys have any questions about like what I did so far before I flip the page over? Everybody good so far? Okay, now I'm gonna flip the page over, which I hate to do in the middle of a problem, but there's dot plots involved. Okay, and then this I put here to be like, that music, the foreboding music of like a horror show. Do, 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 do. Oh no. Okay, so we have the caffeine sample size is 10, which is less than 30. And we have the non-caffeine sample size is 10, which is less than 30. And there's my feelings about the matter. Okay, you have two options here. You can make a dot plot or a box plot. Um, in this particular case, I would do whatever's easier, but in this particular case, I think it's easiest to do a dot plot because they're whole numbers in the table. Does that make sense to everybody? Okay, so I'm just gonna go here. Okay, so when I look at the data, I want to line it up because I'm a nerd. So I'm looking at all the numbers here. What's the lowest of all the numbers here? Not the summary statistics, but all of my data values. What's the lowest? -2. And what's the highest? 8. Okay, so I'm going to make both of my dot plots go from -2 to 8. I did a little extra, that's okay. It's EI. It's EI. I still can't get used to the fact that it's EI. What about the rule? Don't you guys know about the rule? Right, but the C's not like, I mean, there is a C, but the C is way over here, which is not what they mean. Okay. And I'm gonna go up every half box just to save room. So 8, 3, 5, 1, 4, 0, 6, 1, 4, 0. Three, -2, 4, -1, 5, 5, 1, 2, -1, 4. Okay, now, as I told you guys, first of all, this is not giving me a whole lot of information. Can I tell if those look normal or not? Yeah, no. No, I mean, this one even looks like it's kind of skewed. Hopefully your statistics eyebrows going, this doesn't seem quite right. But then what takes over in your body is that Mrs. Talbot says it's an FRQ, you have to keep going. Okay, and what are you going to turn your voice into? The Slim Jim or the monster truck guy? And you'd be like, is it really that bad? No. Is it extreme? No. So what you're going to say is, no, done. And you're going to do that every single time. And it doesn't even matter what it looks like. You're not even going to look at it. You're not even going to analyze it. You're just going to check the box of drawing it because Mrs. Talbot said so. And then you're going to be like, good enough, and then move on. Yeah, it's literally just to meet the requirement of doing that and then move on with life. Okay, however, if you were doing your own experiment in real life and there was some giant outlier out here like 47, you might want to go look back at your data. Also at that person, whoever's pulse rate was 47 different. But anyway, um, does this make sense though? You just do it and you can't really, don't overthink it. Just move on. Okay. Do. Okay. Over here, I'm going to start by finding the statistic, which is X bar caffeine minus X bar no caffeine. X bar caffeine minus X bar no caffeine, 3.2 minus 2 equals 1.2. Everybody good there? Okay, so I'm going to go back here, 1.2 plus or minus. Everybody with me so far? Okay, now I'm going to find T star. And then this is my next teaching moment. What should I use for degrees of freedom? 9. Okay, that's an easy question right now. What if the sample sizes are different? What should I do if the sample sizes are different? Okay, let me ask you this. This is the dumbest question I'm ever going to ask you in your entire life, but what's better, a bigger sample size or a smaller sample size? Okay, so when we're using T star, we need to be conservative about what we're saying. So make a little error, use smaller sample size. You can't say that your study has a bigger sample size than it does. So you have to be conservative and use the smaller one. Otherwise, you're overstating how good your research is. So in this particular one, we don't have to worry, but that's a little bit different from 1,519. Why did I make that look like times? Okay. So now I'm here. Giant square root. Okay. Standard deviation of caffeine. What's the standard deviation of caffeine? Those words don't make any sense, Mrs. Talbot. What's the standard deviation of the caffeine group? 2.7. And sample size of the caffeine group? 10. Standard deviation of the non-caffeine group? 2.624. And their group is also 10. Make sure you're only squaring the tops. So this is kind of hard in the formula sheet. Like, this is a label, this is a label, this is a label, this is a label, but those are actually exponents. Cool, College Board. Thanks for using the same label as your exponent. Awesome. Okay. And you can type this in one fell swoop. You don't need any parentheses, anything fancy, just type her in just how she looks. Can't remember what I wrote. The difference, no, the pulse rate change. Okay. And this is the last thing. Two. It's, I skip a line and then two more lines. I put a sentence here and a sentence there. Okay, so my interval goes from negative 1.49 to positive 3.89. I said the signs on purpose. My interval goes from negative 1.49 change in pulse rate to positive 3.89 change in pulse rate. So can we say that caffeine increases pulse rates from our information? No. Why not? Because 0 is in the interval, which means that there's a possibility of no difference. Right. Okay. Okay, real quick. How do you feel about that conclusion? Because caffeine does increase pulse rate, doesn't it? Yeah, okay. So what do you think that these people could go back and do? I don't know, this is the craziest question of all time. Yeah, go back and ask more people, they'll get a better result. 10 people, yeah. Yeah, exactly, like 10 people is not gonna do anything for you. They have a fundamental problem here. Okay, last thing, real quick, because I'm just a giant nerd, huge amount of nerd. I'm hoping that at least one person in the room noticed that it said students like these. Is anyone, one person, yay, okay, so that's a throwback to chapter 4. Remember, when you have an experiment, you can conclude cause and effect, but you cannot generalize that to the population. So what I'm saying is, if you bring in 20 grandmas and grandpas, you can't say the same thing for them because you used only students in your experiments. I mean, I'm not saying grandma and grandpas can't be students. I'm just making an assumption that those are probably younger people. I don't know how caffeine affects the oldsters. Oh my gosh, yesterday I was driving home from somewhere. I didn't know it. Oh, it was the dump. It was the dump in American Canyon. This is my first time to ever go there and I hope to never go back. But anyway, both of my, I have 4 adult children, 2 biological, 2 step. 2 of them decided to move this weekend. No, that's just move where they live, and which ultimately means that they have a bunch of stuff they wanna throw away, which is great, and we live in Napa, they both moved to Fairview, so of course the dump was on our way home. So guess who got dump duty? Anyway, it's so loud and smells so bad. But, okay, oh, as I was saying, I saw a lady that was so old. She was looking through the bottom of the steering wheel as she was driving. Like she was looking through, she was like this, looking through the steering wheel. I don't. Here is my joke.
Yeah. Complicated.
You're not, where's your reaction to my joke? Poor thing. Hopefully they're not in some kind of makeup factory.